You have briefed a required navigation performance approach using the global positioning system. The weather conditions are low, but still above the minimums for localizer performance with vertical guidance. Everything appears stable, but as you continue inbound, your avionics system changes. The indication for localizer performance with vertical guidance disappears. Now the system shows lateral navigation with vertical navigation, or possibly only lateral navigation. There is no failure message, no warning, just a different level of guidance. So what changed? And more importantly, what is the system actually telling you? Localizer performance with vertical guidance is one of the most advanced capabilities available in satellite-based instrument approaches. It provides both lateral and vertical guidance, similar to a traditional instrument landing system, but without requiring ground-based transmitters. Instead, it relies on the global positioning system, enhanced by the wide area augmentation system. This allows aircraft to achieve highly accurate positioning and descend using a stabilized vertical path to lower decision altitudes. Compared to other types of required navigation performance approaches, localizer performance with vertical guidance offers the highest level of service and the lowest operational minimums. Not all satellite-based approaches provide the same level of capability. Lateral navigation refers to guidance that keeps the aircraft aligned with the runway centerline, but does not provide vertical descent guidance. Lateral navigation with vertical navigation adds a vertical path, typically generated using barometric altitude or satellite augmentation, allowing a more stabilized descent. Localizer performance with vertical guidance provides both lateral and vertical guidance with significantly higher accuracy and integrity, enabling lower decision altitudes and improved precision during the final approach segment. For operators, satellite-based precision approaches reduce reliance on expensive ground infrastructure such as instrument landing systems. Airports that cannot justify installing or maintaining traditional navigation aids can still support precision-like operations. This leads to improved accessibility, reduced weather-related diversions, increased dispatch reliability, and greater operational flexibility. In many regions, this capability is not just an enhancement, it is essential for maintaining consistent and efficient operations. The global positioning system alone does not provide sufficient accuracy or integrity for precision approach operations. The wide area augmentation system enhances global positioning system signals by correcting errors and continuously monitoring system integrity. Ground reference stations measure signal performance and transmit correction data to aircraft. This allows the navigation system to achieve the level of accuracy required for vertical guidance, while also ensuring that the data can be trusted for safety-critical operations. Before the aircraft even begins the approach, the flight management system evaluates the expected level of navigation service. Using satellite geometry, system performance data, and stored procedure information, it predicts whether localizer performance with vertical guidance, lateral navigation with vertical navigation, or only lateral navigation will be available. This prediction allows flight crews to brief the correct minimums in advance and prepare for the appropriate type of approach. As the aircraft approaches the final approach fix, the navigation system performs a final integrity check. If the required level of accuracy and integrity is still available, the approach continues as planned. However, if those requirements can no longer be met, the system will transition to a lower level of service. Localizer performance with vertical guidance may change to lateral navigation with vertical navigation, or further to lateral navigation only. This is not a malfunction. It is a deliberate and required safety function designed to ensure that the guidance being provided meets certification standards at all times. In instrument flight operations, integrity is as important as accuracy. During approaches with vertical guidance, aircraft descend to lower altitudes with limited margin for error. If the system cannot guarantee that the guidance is accurate and reliable, it must remove or downgrade that capability. This protects against incorrect positioning, invalid navigation data, and sensor inconsistencies. The system is designed to never present guidance that could compromise safety. From an engineering and maintenance perspective, this capability depends on a fully integrated and properly certified system. It requires approved avionics equipment, correct software configuration, current navigation databases, proper enunciation logic, and fully functional integrity monitoring systems. Supporting these operations is not simply about installation, it is about ensuring that every component meets regulatory and performance requirements. Understanding system behavior is essential when troubleshooting and maintaining operational reliability. For pilots, understanding the differences between lateral navigation with vertical navigation, and localizer performance with vertical guidance is essential for safe decision-making. For operators, these approaches improve access, efficiency, and reliability. For maintenance professionals, system configuration and integrity are critical to ensuring continued airworthiness. And for the aviation industry as a whole, this technology demonstrates how modern navigation systems prioritize safety through continuous monitoring and intelligent system design. The most critical visual focus in the cockpit centers on the navigation display, the flight management system, the primary flight display, and the mode control panel. The navigation display provides the pilot with a real-time map of the aircraft's position, route, and approach path, making it essential for situational awareness during all phases of flight. The flight management system acts as the core processing unit, calculating navigation solutions, managing the flight plan, and determining the level of guidance available at any given moment. The primary flight display presents the aircraft's attitude, altitude, airspeed, and vertical guidance cues, allowing pilots to maintain precise control and stability, especially during approach. Above these, the mode control panel allows pilots to select and manage autopilot and flight guidance modes, directly influencing how the aircraft responds to navigation inputs. Together, these systems form an integrated environment where accuracy, integrity, and pilot awareness come together to ensure safe and reliable flight operations. At Deep Blue Avionics, we focus on the systems behind the operation, the engineering, the certification, and the integration that ensure aircraft perform safely in real-world conditions. If this breakdown added value to your understanding, subscribe to the channel for more insights into avionics systems, aircraft certification, and advanced navigation technology. Share this with your flight crew, your engineering team, or your maintenance organization, and stay connected as we continue exploring the systems that define modern aviation.